Good morning, everyone. Today we're doing Unit 5, Lesson 5, representing sinusoidal functions. So far we've looked at taking an equation and breaking down the transformations, either on a graph or in a table of values to then graph the transform function. Now we're going to go the other way. We're going to be given a graph and have to come up with the function, or given some information about the transformations and having to come up with the function. So just to review, there are 4 transformations that we've touched upon so far in this unit. Our base function for sine and cosine is here. So we have the sine function here with all those transformations of our vertical stretch or our horizontal stretch or compression, and then our phase shift and our vertical shift. And cosine is here as well. Okay, so just some ones to remember. The d variable within both equations represents our phase shift. So that's a horizontal shift, left or right. And remember, whatever the sign is on the bracket, it's the opposite direction that the graph is going to move. Okay, our next one is a vertical shift. So that's that c value. So that's going to move it up or down. And that phase shift is going to move it right or left. Okay, the a value represents a few different things. Our a value is our vertical stretch, which when we think stretch, we should be thinking multiply. So if our a is greater than 1, it's a stretched vertically, so it's being multiplied. Oops. It's being multiplied by a. Okay, if it's a fraction, it's still being multiplied, but it's being multiplied by 1 over a when it's a fraction, right? So we're still multiplying, but we'll multiply by 1 over a. And finally, if a is negative, so if a is less than 1, then it's reflected in the x-axis, right? The last transformation we've talked about is our horizontal stretch or compression. So k represents a horizontal, that should be a compression. When we think compressed, we should be thinking divided by. So that's why we take our k value and we're dividing everything by that k value. So when our k value is greater than 1, we have our function is being compressed horizontally or divided by k. When it's a fraction, it's still being divided, but it's being divided by 1 over k. So if k is a fraction, we're still dividing by that fraction, which is going to end up making it be more of a stretch than a compression. Okay, so these variables also tell us some information or some properties of our function. So that c, which is our vertical shift, also represents the equation of our axis. Okay. The a value represents our amplitude, which is that distance from our axis up to our maximum or minimum. And then finally, our k value will help determine our period. So when we know our k value, we can take 360 and divide it by k to determine what our period is. Okay, some other ways to find these things, if we don't know exactly our axis or our amplitude, we can use our maximum and minimum. So for our axis is always going to be our maximum plus our minimum divided by 2. Because think about that, we're just averaging our maximum and our minimum because it's right in the middle of them. And our amplitude, we're going to do maximum minus minimum divided by 2 because we're trying to find the distance basically halfway between the maximum and the minimum. And then if we know our period but we don't know our k value, we can just work the other way. So our k value would be equal to 360 divided by our period. And then finally, the last point I want to make is about our key points. So once we know our period, we can determine our key points by taking that period and dividing by 4. So we would say that our key points are every, okay, our key points are every whatever period divided by 4 is, that's how often our key points are going to occur. Okay, so when we're trying to determine which trig function is the best to use, should we use sine or cosine, there's a couple things to consider. So are we going to use sine or should we use cosine? which one should we use? So if we use sine, when we would use sine is when the function starts near the axis. Because remember, so when the function starts near the axis, because if I was to just draw a rough sketch of my sine curve, remember that my sine curve does start at the axis. So if I was to draw a sine, if 0 is my axis, the sine curve goes like this. Right? This is our sine. So we can say it's starting at the axis, right? Our axis is at 0. That's where our sine curve starts. In terms of our cosine, when would we use cosine? We're going to use cosine when the function starts near a maximum or a minimum. So if I was to draw my cosine function, remember my cosine starts at its maximum and then goes down to the minimum, back up to the maximum. So this is our cosine function, our base function. So you can see that our cosine function starts at a max. So that's going to depend on which function we use when we're given some information. So to find the phase shift for sine, it's going to be from the middle to the y-axis, and for cosine, it's going to be from the maximum to the y-axis. So just remember that since our sine curve starts at the middle of the function or at the axis, then to find how much the transform function was shifted, we have to determine, okay, where's the first time the function hits the midpoint or the axis? That's how much they must have shifted the graph. For our cosine function, because our cosine starts at our maximum, then we're going to determine how much did that maximum get shifted from the origin. Okay, and the best equation of a curve that has the least amount of phase shift and a positive a value. So the best equation is always going to be the one that has the least amount of phase shift and a positive a value. And we'll get into more of this as we kind of look at some examples. So let's look at an example. Okay, so we're going to find the equation of the following curve. So we're going to take a look here and try to determine a couple things to see, should we use our sine curve or should we use our cosine curve? So let's, first of all, we can easily see what our maximum and our minimums are, right? Because if the graph started near our maximum, meaning if the maximum was on the y-axis, so if the maximum was somewhere over here, then we'd want to use our cosine, but it's not. So we're going to see exactly where is the axis of this curve, because if the axis starts on the y-axis, then we're going to use our sine. So remember, our axis is equal to our max plus our minimum divided by 2. So my maximum is right here at 5, and my minimum is down here at -3. So if I wanted to find my axis, I would say, okay, my max is 5 plus my minimum of -3 divided by 2. So 5 plus -3 is 2. 2 divided by 2 is 1. So the axis of my curve is at y equals 1. Okay, and you can see that that axis is exactly where the graph starts. So the graph starts at axis. So since it starts at the axis, we're going to use our sine function. So we're going to transform y equals the sine of theta for this graph, because that's going to require no phase shift since it starts right at the axis. So because it starts at the axis, we're going to use our sine of theta. So let's start figuring out some information. And remember, if we wanted to recall what that transform function looks like or where those variables are, I'll just write it up here. So y equals a times the sine of, and then in brackets k, and in another brackets, theta minus d plus c. Okay, so we got to figure out all of those variables to write our transform function. We have to figure out what's a, what's k, what's d, and what's c. All right, so if we wanted to determine our axis, well, we already determined that. That is at y equals 1. And remember that our axis also tells us what our vertical shift is. So Since our axis is 1, our vertical shift is also 1, and that is my C variable. Okay, our amplitude is the distance from our axis to our maximum or to our minimum. So if I'm at 1 here, up to my axis is going to be 1 to 5 is 4. So that's going to be our amplitude. Our amplitude is 4. And remember, our amplitude in terms of our equation is our A value. And then our phase shift is how much did we have to shift it left or right, which is represented by that D variable. Okay, since the graph started right at the axis, there was no phase shift. All right, let's evaluate how long a period is. So if we're saying that the graph starts at my axis, how long does it take before it repeats that curve? Right there is where it starts to repeat the cycle again. So that is at 180 degrees. So if we need to determine our K value, well, our K value is going to be 360 divided by our period. I'm just going to draw an arrow here. So 360 divided by our period, which means our K value is 2. Okay, so we've determined all of those variables that we can now plug in. We have our C, our A, our D, and our K. So we will just substitute those into the transform function for sine. So we will have that y equals my A value, which is 4, and then sine, and then my first set of brackets is my K, which is 2, and then in your other brackets we have theta minus D, well, D in this case is 0, so we can just close our brackets, plus our C value, which is 1. Okay, and that's the transform function of that graph based on our sine curve. I'm going to get you guys started on the next one in terms of deciding which function are we going to use, and then I'll have you guys go ahead and try to determine the equation. So for this one, again, we always have to figure out, okay, where's my axis, where's my maximum and minimum, and then which one is it closer to starting at on the y-axis. So let's start with our axis again. So our axis is going to be our maximum, which our maximum we can say is here at 1, plus our minimum. We have our max, and we have our min. Okay, so I have a maximum of 1, and I have a minimum of -5. We're going to add those together and divide by 2. So 1 plus -5 is -4. -4 divided by 2 is a -2. So I'm going to draw my axis there so I can see, is the axis or is the maximum closer to that y-intercept? Okay, so my axis we don't hit my axis until around 60 degrees. If I look, I have my maximum over here on the negative side of my graph, but my maximum is only 30 degrees away from the y-axis. So we're actually closer to our maximum. So we're going to say that the graph starts close to our max. So we're going to use cosine. We just have to take into account how much they have to shift that cosine function in order for it to start now 30 degrees to the left instead of right there on our y-axis. So I'm going to pause that video, see if you guys can identify these properties of the graph and then translate that into an equation. Okay, so there's your transform function here. We were able to identify all of our variables and then plug it into the function. One thing I wanted to make note of here is with our phase shift. Okay, we shifted our maximum from here. Right, we shifted our maximum from the y-axis over here. So that is 30 degrees to the left. We shifted from our base function of cosine. So in order to make a phase shift go left, we have to make it a positive 30, right? It switches its sign inside of our bracket. So that's why that's a positive 30. Also, the period here is still 360 degrees, right? It didn't change from our base function. So our K value just stays at 1. And we can show that mathematically by just doing 360 divided by 360, which is 1. So our transform function is y equals 3 times the cosine, and then in brackets, theta plus 30 minus 2. Okay, we're going to try to come up with the equation now based on just given some information. So this time we have, we're going to write an equation and it's telling us to write it in terms of sine, and then we are going to try to graph a few of the cycles. So write an equation of the form y equals a, and so on for the sine function that represents the following transformations. The base function has been reflected in the x-axis, so let's just highlight some of that. So it's the base function has been reflected in the x-axis. We have a vertical stretch by 2. It's been horizontally compressed by 1/3, shifted 45 degrees left, and translated 1 unit up. Okay, so we have to start thinking about what does each of these things represent in terms of those variables a, k, d, and c. So let's see if we can identify that. So if it's reflected in the x-axis, that's going to affect our a value. So this means that we're going to have a negative a value. Okay, it's vertically stretched by a factor of 2, so that is our a value. So now we just know we have to have a negative 2. If it's horizontally compressed by 1/3, that represents our k value. If it's shifted 45 degrees left, that's my phase shift. So you have to remember which variable is my phase shift, and that's our d variable. And then finally, if it's translated 1 unit up, that represents our vertical shift, which is our c. So my a value is going to be a negative 2 because it's stretched 2, but it's also reflected in the x-axis. And then our k value is 1/3. Our d value is 45 degrees left. So again, if I want it to go left, I have to make it a plus 45. And then it's 1 unit up, which means it's just going to be a positive 1. Okay. We're going to write our equation, and then we're going to put that into a table of values to see about graphing it on here. So our equation is going to be y equals a negative 2 sine of 1/3 theta plus 45. I'm going to put an extra set of brackets there so it's not too confusing. Plus 1, okay? And we're going to use the mapping tool to go ahead and graph this function. So we could start by, of course, graphing just our base function of sine. And we should all know what that looks like by now. Okay, so that's just our base sine function. And then we will graph our transformed one as well. Y equals a sine of theta. Okay, so if we were to put in those base functions with their key points, we know that the key points are at 0, 90, 180, 270, and 360. And it starts at our axis, which is at 0, goes up to our max, down to the axis, down to our minimum, and then back up to our axis. So now, in terms of our transform function, we're going to look at the transformations happening here. Remember that my theta is going to be affected by the stuff inside the brackets. So my theta gets all this stuff inside of our brackets. That's what's affected there. So our theta is going to be divided by 1/3. And then we're going to subtract 45 because it's opposite of what's going on there, right? So we divide by the 1/3 and we subtract 45. My y values are going to be affected by the stuff outside the bracket. So my y values are affected by the negative 2 and that positive 1. So it's going to be a negative 2 times y and then plus that 1. So that's how we'll determine all of our transform points. So if I take my theta and I divide it by 1/3, 0 divided by 1/3 is still just 0 minus 45. Okay, 90 divided by 1/3 is actually 270, and then 270 minus 45 is 225. I'm going to pause the video here. Go ahead and finish the table of values for your thetas and for your y values, and then plot that on the graph, and then we will come back together to fill out that next table under part B. Okay, so we have our table completely filled in, and then we've graphed the points we have. If we wanted to extend this on the left-hand side, we would just have to figure out what the pattern is here. So it looks like we have a key point, so from 225 to negative 445. Okay, so to go from 225 to negative 45, we have a key point every 270 degrees. So we'd have to go back another 270 from that negative 45, which would put us at negative 315. So negative 315, and then up to 3 there as well, because we're going up to our maximum from there to stay with the pattern. So it looks something like that coming down. All right, and that would be that function transform. So if we wanted to fill out this other table here, part B for graphing the function that identifies some of the properties of the graph, we could do that. Some of those values we could find just from identifying the variables, but we can also determine them from our graph. So our axis is going to be the same as our C value, which is at negative 1, or sorry, positive 1. So my axis is what cuts that graph in half. And you could do your maximum and your plus your minimum divided by 2, but you could just take it from your C value. So it's going to be at y equals 1. And remember that also determines your vertical shift, which is at 1. Our amplitude, again, we can go from our axis up to our maximum and see that that's 2. So that's our amplitude. Or we can look at our equation, and our A value also tells us our amplitude. Right? So our A value tells us our amplitude. Our phase shift is how much did we have to shift that sine function to where the transform function starts. And if we look, okay, remember our sine function usually starts at the axis. So this is the closest axis point to my y-intercept. And that looks like it shifted 45 degrees to the left, which you can see means it's a plus 45, which is what our D value is. So our phase shift is 45 degrees left. Our period from this one, we could assess what our period is if we go from a negative 315 all the way to a positive 765, right? We could figure that out. We can also figure that out by dividing by our K value. So if we did 360 divided by our K value, which is 1/3, our period would be 1080 degrees. And again, our K value is 1/3. So you can see how using the graph, or just by once you identify those variables, A, K, D, and C, you can identify some of those properties on the graph. Okay, we're going to try one more for today. All right, so here, again, you're given some information about the function, and we're transforming a cosine function this time. So go ahead and work through A and B and graphing the function, and then we'll come back together and do C together. But try to identify the variables, identify the equation, identify the properties of the graph, and graph the function. Okay, so here's our transform function. Okay, we transform the cosine function. It's been stretched vertically, but it's been compressed horizontally quite a bit. So some things to notice here is I've only graphed one of the cycles, but we could extend this to 2 cycles by just following the pattern. So I identified how often we're going to have a key point. So you can see we're going to have a key point every 45 degrees. Because I took my period of 180 and divided it by 4, that'll tell me how often there's a key point. So it's going to be every 45 degrees. So we're just going to follow the pattern of what's happening for my cosine function. So if I wanted to extend my graph to the left, I'm going to go from this point at 60 and 8, and I know I'm going to have to come back down to the axis, right? So I'm going to have to go back down this way. But how far horizontally am I going over? I know my axis is at 3, right? You can see my axis is here. This is our axis at y equals 3. Okay, so our key points are every 45 degrees. So right now I'm at 60 degrees, so I'm going to have to go to 15 degrees to come back down to my axis. And then if I wanted to continue, then I need to go to my minimum from there. I'm going to have to go another 45 degrees. So I'm at 15, so another 45 degrees would be at negative 30 and down to my minimum. which is -2. So we could extend it even further there. And if we wanted to extend the graph to the right, we could as well. So on my right-hand side, I'm at my maximum again. I'm going to have to come down to my minimum from there. So I'm at 240 right now. So go 45 degrees. That would be 285. So it's 270. 285 would be right there. And then another 45 degrees would be at 330. So at 330, I'm going to go down to my minimum, which is at a -2. You're just following the pattern of that graph. Okay, and that's how we could extend the graph. So this is our transformed cosine function, which is 5 and then cos in brackets. We have 2 theta minus 60 plus 3. Couldn't squeeze it all in there. Okay, part C, which I want to do together, says write the equation as a sine function. So we took this as a phase shift of 60 degrees to the right. So for my cosine function, we had a phase shift 60 degrees right for cosine, because our cosine starts at our max. If we wanted to look at this in terms of a sine shift, well, we know our sine starts at our axis. So we have to determine which axis point is the closest to my y axis. So this is the first time the graph touches the axis. So if we wanted to look at this in terms of a sine shift, we could see that from our y-axis to the first time we hit our axis on the graph, we have a 15-degree shift to the right for our sine curve. Okay, so if we have a 15-degree shift to the right, that's going to represent our d variable. So 15 to the right means we're going to have a -15. Everything else should stay the same. We have to remember that for our sine starts at the axis. Okay, our A value, our amplitude, is still going to be 5. Our K is still going to be 2, because if we look, we still are completing one cycle of the sine curve in 180 degrees. If I was to trace how long it took to complete one period, starts there at 15 and goes all the way there to 195. So I still have a period of 180 degrees. So that means my K value is going to be 2. And our C value, which is our axis, is still at 3. So the only thing that's really going to change is our phase shift. So we're going to have y equals 5 times the sine of 2 theta minus that new phase shift, which is 15, right? That's the only part that changed, plus 3. Everything else stayed the same. It's always going to be the phase shift, because remember, our sine starts at our axis and our cosine starts at the max. That is it for your notes for today.